It's time to unwrap the first alumni talk of College of Engineering Alumni Association Kannur, CEAAK. I invite Dr. Jafar Ali Parol, alumnus 1994 to 1998, Civil Engineering Department, to convey the talk. Welcome, sir.
Hi, good morning, everyone. Am I audible?
Yes, sir, you are audible.
Okay, thank you. Uh, Thank you for inviting me for this event of the first alumni talk. As usual, um we for the corporates and the scientists, if you are researchers, if someone asks us to deliver a talk, we come and prepare a huge number of slides, and I came in the same fashion with you see the lots of content. But after listening to the inaugural session, I thought I will touch upon a couple of points, being this is an opening session for one of the purposes, as I understand, is a brainstorming for the activities. So I'll touch upon a couple of points which was mentioned by the previous speakers. Before I go into this, I really thank Dr. Rajesh and Sunil and Dr. Jayaprakash for inviting me for this event. I don't know is Dr. Jayaprakash is there currently. I hope. So let me touch upon a couple of things. This alumni event, an event like this, is a very good opportunity for networking, which we all know that networking is a key for our career development and many more. So this can help not only for the passing out students or the young pass outs undergraduate students, but also for an opportunity for every alumnus to contribute for our college. For example, many of us want to contribute to the institute in various capacities. So I think it's also a platform for us to be part of this, either in delivering talk or offering various things for the institute. And at the same time, I think for the students, this is a really, really great opportunity to connect with the industries to make the most of it. See, one of the thing which I thought I should touch upon is as we have planned the series talk, the technical talk, then I think the job fair, yeah, that's what I understand, the job fair, plus the magazines. See, one of the when I interact, I interact a lot with students, especially they come to work with us while I was working as a scientist in defense or NAL, and even during my current role. One thing I have seen is what is missing in general. It is not only an issue for the uh, institutes like us. Overall, it's an overall issue of institutes in Kerala, that the industry training. I think this is one part the alumni can contribute to a really a great extent. So see, for example, if we there is a connect. If you come out of as a student, and once you enter in a professional career, there is a huge change in terms of our the way we deal things and how we take up things. For example, our independence. If we give a problem, are they able to solve these problems independently? Because especially when we graduated, we have all uh, are very good at various solving the theoretical problems, but that too with a sort of help, taking from the peers. That's fine. That is perfectly all right to take the most resource around us. But it is also, we also have to have that independence to take certain activities to solve the real class, the practical problems. So I think the industry training will prepare the student for their next responsibilities. See, many of us, the many of us don't even know our real interest when we take a course. For example, a mechanical engineering. I was actually talking to my nephew past few weeks, where he said he wanted to do a mechanical engineering. Then I asked him, why do you want to do a mechanical engineering? He said he likes cars and things, so he want to contribute on the automotive industry. The idea what they think is, we do not know what is a mechanical engineering, what all we can contribute. If we want to contribute, should I do only a mechanical engineering? Do I have another option? So we tend to learn after our undergraduate. Oh, this is not what I want to do. So we still have an opportunity to change. But my idea, my the it is very important, if we get a culture of industry training every year. I think Hari, Hari Kishore was mentioning from the IIT. Many of them start their industry training from the first year. I think this is exactly what a good institute does, because it actually gives a lot of confidence for the passing out students. I have had a collaborative project with MIT United States. There, from the first year undergraduate students, I remember one of the student who came to Kuwait, and she presented, and the faculty was telling she just joined for the first year. So at the right away, once they are into the student in the college, apart from their studies, they are also partially some the work is involved, and they are exposed to things, and they really are prepared, and that's how the confidence the confidence also boost up for them, and they get prepared for the work. The other thing which I have noted in um, our institute, Kannur Engineering College. Maybe I am not much aware, but just I'm not sure how many professional organization, for example, IEEE, for example, Institution of Engineers, American Society of Mechanic, ASME, ASC. Are there any association there in the institute? Can anybody help me? Hello? Hello? Yes. Anyway,
Sir?
yes. Am I audible?
Yes, sir.
Yes, I'm asking a question. Is there any professional organization like AEEE chapters
Yes,
or
sir.
a similar? Okay, very good. So I think this is very important. This you have to this professional activity chapters has to be active, more activated. Like this, look at this now. The alumni chapter, alumni has got a real life, or I think planning with something great event. So I think it's as a student coming out of the institute, to have a good confidence, I think they should be really part of this professional organization. Very recently, I met a student in one of the conference, and the conference was related to education. And interestingly, this student is from a computer science engineering, and she said, she told me, I was asking, she was talking about the education in the rural area of schools and what they have done and so on and so forth. It was very impressive. So I asked them, how did you then? I asked her, you are a computer science student, final year. Um, uh, uh, your presentations are on what they have done, something for the schools in the neighborhood of their institute. So this is, I think, these activities, she said, it is planned through this professional organization. So I would strongly recommend to reactivate and to plan more activities so that the students participate in the professional organizations, this IEEE, and this actually helped them to network more. I would say that you network, and network. It's very important. It's extremely important to gain the confidence in us when you pass out, and networking will also help you to understand what exactly you wanted. Many of us, once we complete our course, we really might want to switch some area of our interest. But um, um, uh, uh, when we plan this job and things, at the end of the course, I think it would be your options will be much less. For example, Hari Kishore mentioned that everyone prepare from the first year of their undergraduate. They have some, their exposure level is too high, and many times you understand that when you do various activities during your undergraduate course, I think they will really come to know what exactly they want to do, and they can really plan for look for a job of their interest. So I think this participating and reactivating this professional organization, and with some good involvement. I don't know how the college can assist on this, so it would be really helpful. Maybe this alumni should think how to contribute on that aspect as well. The other thing is, maybe we should, I don't know how many students coming out of this institute, our college now, is going for a conference. Way back in our time, I think for the first time we went out of the college for the part of the work was when we were in the final year, where there was a project for our one of the faculties in civil engineering at our department at that time, to do a survey for the entire Kannur town. So that was the first work which we realized that certain things which we learned are really useful, and that was one experience. And the other thing which we started looking at a research paper or an industry paper was for our seminar. We did not know how to read a paper. So this is not the case for the for the students coming out of other colleges. Anyway, I will reduce the content in my talk. I will rush through, but I think I will, instead of going through the technical thing, I will touch upon a couple of points to share my view. One of the speakers, I can't remember who talked about the social contribution. I think this is very critical from for our institute at various capacities. Is not only from the alumni association, and also at the institution level. I think we should really encourage to make a really social contribution in the neighborhood, or even the remote areas where, for example, one thing which we can do is on the technology part, or how to help on the education schools, how to get attached with the schools. There are so many things that which I can suggest where we can do in association with education. So I think this one maybe we should really should consider from the, I think maybe this should be taken from the institute plus with the help of this alumni association. I don't know how much it can take it further, but I think this is very important as well. And when we participate, my experience is when we participate in these activities, those who are participating, they have, it's actually a really, really great experience for them as well. So that will help them. This is the first step for the work. So I think this is important. It's not only a social contribution, and it is also a self-development and learning for those who are participating. But I think this should be taken as well. One of the things Dr. Jayaprakash was mentioning, it's very impressive that there are the research culture is now inherent part of the institute. There are several PhDs going out. Maybe the other thing what we should do to enhance the brand of the institute, I think we should have at the faculties level to have more collaborations with industries, either to a consultancy. What happens once you have more project with it can be an R&D project or the consultancy project, that is also will benefit to the students, so they can you have a huge resource around you. So I think the collaboration part and it's a huge faculty development for the faculties also. It's a really great opportunity to network and develop. So I think with that maybe I will start the talk which I prepared. Maybe I'll try to rush through because we are already running too late. Before I choose this topic, interdisciplinary research and opportunities. And as many of the speakers shared, when we went out or when we pass out of this college, we don't have a confidence in us. Are we really useful, or what exactly are we really competent enough compared to the students coming out of other institute like IITs or NITs, and or even the branch wise, civil engineering, mechanical engineering. I would like to show some of the things that most of us coming irrespective of the branches, we see that we all have studied almost the same. We can and a civil engineer can contribute into problems which we think only an electronics and communication people, for example, signal processing. We actually are studying certain we all of us are have already some technical skills which we learned from during our course itself. And I will show you some of the problems which we think it is a core to there, but it is cutting across various branches in various branches of engineering. So I have chosen these pictures. I think you can see. Can you see my next slide? Can anybody from the online respond?
Yes, sir. We can see the slide.
This is yeah. Okay, very good. I just want to make sure it is moving. Okay, this is a computation model. We say the finite element model of one is a wind turbine tower and an aircraft structure, and this is a tall building. This is a finite element model, or let me say call a computational model. When I started my career after my undergraduate in civil engineering, then I did my master's in structural engineering. The first industry I started with was at National Aerospace Laboratories. That's an aerospace industry where we work on the civil aircraft Saras. So I started working on finite modeling of aircraft structures. I worked there for a couple of years with a civil engineering and structural engineering background. Later, I moved into Ministry of Defense, where again I was working on fighter jets, light combat aircraft. Again, some of the things which I learned were able to use, and started modeling the light combat aircraft, the full, much more large scale that what I was doing at NAL, National Aerospace Laboratories, I started modeling the complete fuselage, where we do various maneuvers of the full aircraft at various, and we interact with the pilot to ask to conduct various specialized maneuvers, and we check the structural strains and so on and so forth post these flight tests and several other components. I worked there for 4 years and then left, and I joined at GE General Electric. Mostly it is I think it is for mechanical engineers or other other branches of engineering. We have seen that any branches which we complete, we have seen that we work on software that quite common. But I'm talking about the core technical work itself, with the different branches and different branches we can contribute, and you actually study some of the skills. So then I worked as a technical leader at GE, where I was involved in the design. I was a technical leader there for the design of last stage rotating blade of a steam turbine, which I had no clue. That's a completely different software what I was using at ADA, software or the tools, but I was on doing the modeling of the rotating blade. Then after that, I came back to Kuwait, and I started working on something related to which I thought it is civil engineering. I started with concrete, now into structural health monitoring. But again, coming to the computer finite element modeling, I started modeling the finite element modeling of buildings and bridges and the concrete structures. Why was I able to do work on various industries it's very interesting that the mathematical model of these physical problems are described by the same equations, similar equations. It's not only on structural mechanics. Some of these equations, you will see that it is coming to an electrical engineer. I will show you your electrical core engineering, or even for your heat transfer problems. So and interestingly, some of this we study at the very first year of our engineering itself. So let me go to my next slide. Again, these are some of the finite element results which we worked on. These are some pictures which I have worked on, and you see on the left corner is the finite element analysis results of a rotating blade, the last stage blade of a steam turbine. And these two are the rest of the pictures are the finite element model which we did when in the first few years of my career at Kuwait. This is on the complete finite element modeling of reinforced concrete. So the idea which I would like to share is that there are common things which we all learn, either it is a mechanical engineer or civil engineer, and we are actually prepared to contribute into various industries. Even if you do civil engineering, there is a great opportunity to work on an aerospace projects, or an automotive industry, where if you want to, most of the structural analysis, you can contribute in a great scale on the mechanical analysis of various components. And if you want to contribute on the automotive industry, you don't have to really go into the mechanical engineering, so because sometimes we tend to choose our interests based on the newses and the things which we see. And so I think it is very important to understand this aspect, to start a connection with the industry right from the first year of uh, uh, um, uh, uh, when first year of our academic studies. And I think the alumni should really consider this, exposing all the students, not to limiting only the final year or the recently passed out. I think it will be really useful for them to understand how what they can contribute and how they can prepare themselves for their next role. I will just show you when I started working at ADA. The one of the first project what I worked was the modeling of what they call as a drop tank. It's an external fuel tank which is attached to the wing. And once the fuel is used from the tank, the tank can be dropped and after completing the mission. So it's a very interesting problem which we have worked on, where the finite element modeling of this drop tank is done. The boundary conditions was something very, very interesting. It has a mechanical connections where with the hook and bushes. So the boundary conditions was very interesting. It's non-linear because during the flight itself it changes. I started this work, completed the entire design. So I've got this video from the complete fuel, the testing of this. So this is the static test where the drop tank is dropped after using. This is a real in-flight test, and this is the complete load test where how the strains, and this is a complete static load test. And what you saw just previously about a sloshing test on the various walls. So this is the static test you can see. So there are various programs available, very, very interesting projects, and very, very high level, very, very, very interesting and project. Many of this project may not be available in the public, but when you get a connection to the industry, when you go in, even if you as a student, you will start get exposed to such very interesting project. And once you work on it, you will really know you really want to. Yeah, I was talking in between. So I just shared this. So I think the industry connection is very, very important to understand this. For example, as far as I know, well, while I was working in institute like National Aerospace Laboratories and in DRDOs, there are various very interesting programs which the public may not be aware. And many of the students, many of us may want to contribute just because we did not know how to enter. So I think the alumni, it's not only for the job fair, that industry training is a very important, and one another most important, and it all comes from the students initiative. This is a very, very important. When I look at the participation in the online, I don't see. I can imagine the limitation on in the physical, physical attendance, but I don't see much of the students. So I think it is very important. Maybe somehow it is to be conveyed for them during a regular interaction. So it is very important for them also So I don't want to go too much into differential equations. Usually I cannot avoid anything without equations, but I think we already had enough talk. I will rush through, but just I will tell you this is the differential equation which mechanical engineers. I don't know if there is anybody from mechanical engineering, Dr. Mahesh, or the rest of the team. But anyway, this d square t by dx square, it's we for us it's a differential, in general it's a differential equation. And you know that the same problem, if I ask Dr. Rajesh, he will say that this differential equation represents the deformation of a tall building due to its self weight. But someone else, mechanical engineer, will say that no, it's a heat transfer problem. If you heat one side of a plate and how the temperature transform to the other side. So the idea, and we solve this problem. This is very, if you ask any first year undergraduate student, he can solve this problem with a direct integration, right? C1x plus C2, and this is actually, it solves a very complex problem. And most of the, so the point is these students are really equipped. I must tell you that they have a really good tool right from the first year. I'll tell you, most of the work which I am currently doing even in the machine learning, what with artificial intelligence, at most of the things what we think it is advanced, I think the first year of the mathematical basis actually prepare them to contribute into the real world, real real problems in the industry. This is, I thought I would share. This was a very interesting project which I involved in while I was working at National Aerospace Laboratories. That was one of my first place where I worked. I worked as at the Center for Mathematical Modeling and Computer Simulation, one division at NAL. Hello, am I audible?
Yes, you are.
Yes.
Yes. Sorry, because I got a call from Dr. Rajesh. Maybe Rajesh, just okay. Let me just. Should I? Within how much time I should conclude? Accordingly, I will skip few things and.
Dr. Jafar, actually, we are planning to wind up this session before lunch. So, if we
Yes,
can take,
maybe in 10 minutes.
within 10
No,
minutes
that's
or
fine.
15 minutes.
It's okay. You can tell what is your next plan, because I do not know the post plan. In 10 minutes, 5 minutes, maybe 10 minutes. Hello.
Yes, sir.
Okay, I will conclude. Let me rush. So this was a very interesting project where this is again, whenever I say the networking is a key, this was a project where the government of India planned to develop an in-house software for computational modeling. Actually, this is to address some crisis. For example, when they faced during the when we tested the nuclear testing, we had sanctions. So one of them was we were not allowed to use this sophisticated software for aerospace application, defense application. So we wanted some in-house. So I worked on this problem where we implemented one element known as a quad 4. And do you know that this quad for a single element, you can, so this model, this is the finite element model, an approximate model for a differential equation for a two-dimensional uh, uh, plate. So it can be either shell. So from my experience, 99% of the mechanical problems can be modeled. Can be a building, it can be an aircraft, it can be any automotive cars, or you name it, any can be modeled using a quad 4. Yes, this is what I would think. This is again, we study this, we all solve this equation in our first year engineering. And I think the first, the electrical engineer, they call the linear circuit model. And they use this equation. And the second one is what we call the structural dynamics. Civil engineers, we say that it is the vibration of buildings. Mechanical engineers say that it is the vibration of cars. The vibration of cars. Aerospace engineers will say it is the vibration of aircrafts. If you ask a mathematical, I think all of you have solved this. This is a homogeneous equation, and so I think all of you might have solved this as a complementary function. Or once you have a right-hand non-homogeneous and non-zero term, either any harmonic or any arbitrary function, you have a complementary solution and plus the particular integral. I'm talking about the student's term, but at the end of the day, these are actually solving a very complex phenomenon in the field. Again, we all study almost the same. So this is I have prepared just for the talk. I just prepared this graph 2 days ago just to demonstrate for the solution of this. This is nothing but the vibration of any structure, whether it can be an aircraft or in your case they call the RLC circuit. And if you subject to a step load, and this is really one area which I am currently working on is a structural health monitoring, which I thought this is again, we are using many things which we learned again in our first year undergraduate fast Fourier transformation. In this case, what we do, we put sensors at different locations of the building, and we collect the data and we predict the performance of the building. For example, the performance, how a building moves during an earthquake. But mathematically, how is it done? When we collect some data, some measurement, these are all time series data, and the moment we have time series data, if you have to extract certain things out of it, I think if you ask a signal processing person, they say it's a system identification. For us, it is these system properties are nothing but the building frequencies, mode shapes, and damping, and few other things. But at the end of the day, whatever this signal processing, whatever we are doing, we have all using techniques which we learned in our first year undergraduate F50. If I have a signal, anybody can. You might have studied, but you may not have solved that. We haven't solved such in a real signal either through a computer. So I think so this is what it helps them to understand. They get once they go to industry, they will have the confidence. Oh, I have the signal. Can you extract this system parameter? Oh, I studied this. I can do this. I think such confidence will come in. So this is a very very detailed one of the picture which I took from a recent paper of ours. We use a stochastic subspace identification method to identify some parameters of the building. But again, I'm just telling you that it is cutting across it, irrespective of buildings, wind turbines or aircraft, or even the signal processing. A simple signal, an electrical engineer, they use stochastic subspace identification method. Again, I think I will skip all these. These are the output from our results. This is an FFT results. You can see how it is related with the total solution. This is again, I think I will go. Okay, this is a very interesting work which we did. You can see the video. This is the vibration of a bridge. Do you know that actually I get we in structural health monitoring, in my traditional way, we put sensors and to measure the data. But recently we did a very interesting work. Just from the video of the vibration data, we can extract some of the very important system parameters, such as the natural frequencies, mode shapes, and damping. And once you know this, we can actually relate to whether any damage has happened or not, because these parameters, I think the technical talk I can defer it maybe in some later talk specific to this. So basically, look at this. Just take a video, and if you ask anybody to process an image processing, this is a paper we published on this. We have done this testing in my lab itself. Simple frame, and we have extracted. The vibration is visible. The amplitude of vibration is quite high. But in a normal case, if you take the video of a normal building where you don't see any vibrations, so in that case, we can use some magnification technique of each frame, and we were able to extract. So I think I will skip. And this is a very interesting. We all have studied about eigenvalue problems in our first year undergraduate, and we have all extracted the eigenvectors, and really what we the eigenvalue problem is one of the major thing which is cutting across. It has cutting across all various problems. So for structural engineers, one of the things which we say, the vibration of the buildings, and even your first the RLC circuit on the right hand side 0, that's also an eigenvalue problem. So anyway, so eigenvalue problem, it has its own mathematical significance, and the physical significance is different. I think I can talk about it, but the whole idea is the things which we all know how to solve an eigenvalue problem. And we will once from the first year, and when they go higher up and they come across various problems, but we were not looking at we don't connect things. For example, I have solved the principal stresses in my third or fourth semester undergraduate, and I have studied the eigenvalue problems in first year, but we don't connect those things. Those are actually eigenvalue problem. For example, the stability problem, buckling, and this is a work which I did with an MIT, where we are using GPS to monitor the movement of the building. This is again the combination of how a building is. We actually recorded. All of you might have heard read the earthquake that happened in Turkey recently. That's actually 1,300 kilometers away from Kuwait. We have recorded the movement of this building from our other sensors, also from the GPS. And usually when we say GPS, we use GPS to measure the building movement, and we are talking about in terms of millimeters. This is actually how a building moves just because of your environmental effect. This is a smart bridge we implemented in Kuwait. I think I will skip through. I would like to, this is an article which I thought, because when it comes to artificial intelligence, I think I must, it's a good idea just to mention it. You know, when it comes, for example, when I do the smart bridge or the monitoring of the buildings or the wind turbine tower, we use physical parameters. But once, if you just treat as a data these days, earlier, just 5 years ago, AI was, to me, was just a buzzword from my own experience, though I have been using this technique for a while. Just 5 years ago, it was a buzzword, but now it is absolutely, it is so accurate. It is sometimes things which we cannot see very accurately, it can predict. And you see the similarity. It is once you measure the data, whether it is building deformation or any other data, whether it is a weight from shopping items. So you can, the data is a data, and it can extract very meaningful, very useful information purely from the data point of view. We have actually a couple of papers on how to identify damages in the building. And I myself really surprised how accurate it is, just purely from the data and the indicators to identify the damage. There is no physical meaning, but the machine learning, the parameters which they identify to predict the anomalies of the data are so accurate. Again, again, I said the interdisciplinary research. This is a technique which is used actually by the seismologist. And when you say seismologists, we think that only they use. But again, this is our first year. We all study impulse response function. On if you have an arbitrary, the two differential equations which I showed in the beginning, if you have an arbitrary function on the right hand side, we all have solved this using impulse response function. We use this, This is actually which I used. I got a query recently. They want to predict the movement of an earthquake or say, but they don't have a structural drawing. So I suggested this method for making the measurement and calculating the IRF, and then predicting the movement of the building. This is a very good paper which we published along with MIT. Now I think I will again, as which I talk about, the technologies are growing really fast. I can really feel it. When you talk about machine learning, I think just 2 years ago, we were thinking that transfer learning is the key. So we started work on taking measurement from some building, and then how to interpret this result for other building using machine learning. Then things are changing. This now they say the physics informed machine learning. So I think the technology is growing fast, and this is what we recently worked on: physics informed machine learning, how to estimate the system parameters if you pass out some information. This we have demonstrated. This we're working on a paper. This is very interesting. The column interaction diagram is only for civil engineers, and we have actually recently worked on interestingly, the research assistant who was working with me, an electrical engineer, and he gave me a really interesting idea. He asked me, I think Rajesh will know, on the left bottom side, this is a column interaction diagram. Why are we putting on the M on the x-axis, a P on the y-axis? He asked me, why can't we invert it? So I did that. So it's at the end of the day, these are mathematical equations. This civil engineers, we say there's a strength, this FSI, whatever it is, the strength of the stresses in the steel. But for mathematician, it's a step function like this. What I see. Anyway, I think this is a work which we did collaborative with Rice University, published in Nature, how to identify cracks, micro cracks in concrete with nano. So it's again. So I think with that I conclude, and I really thank you very much. But I really hope that this initiative goes and we continue this. And I hope I can, from our end also, we are there. But I think there are more things also should, everybody can contribute towards this. And I really congratulate. This is really great initiative. I would say that one of the best, and I hope we will continue this run. And I think we should take it as a marathon. So thank you very much, Rajesh. I particularly thank Rajesh. Rajesh I think he was there all day yesterday. He was called me, Jafar, can we do a demo test? And I really appreciate all your effort. And we will also be there to whatever capacity we can. Thank you. I can see Shankar Ram is waiting. Shankar, I think he's waiting. Are you still in the office or?
Yes. I am in
Okay,
the
thank you. I don't want to take any more. Thank you so much. Thank you.